So a brief overview of attribute tables in GIS. With GIS, once again, we can think that in GIS we have one side of GIS, which is the geographic portion, which is shown on the left here, and we have the other side, which is the information systems portion, or the database, shown on the right here. So in this example here for Washington State, part of Washington State, each of the counties, such as King County, has one row in the attribute table that's associated with it. So every feature on the map has one row in the attribute table. But the attribute table can have many columns just depending on what sort of information is stored there. In this example, there's a FIPS, a population for 1990, the area of each county, and the population density. But we could have hundreds of more columns depending on what information we want to store in this database and how we're doing that. So if we just want to store information in kind of a matrix, why don't we just use a spreadsheet, or sometimes this is called a flat file. The reason we don't want to use that is because we don't want to waste space on the computer. And I think you can kind of see how space can be wasted by all of these empty cells here. So why are some of these cells empty? Well, this is to track orders for a company, and here are their customers here. They include their addresses. They include their phone number, and then each time they call on the phone and make an order, or on the computer make an order, they include an order number here. So we can see this would all be fine if it were just the first two orders there from Leo and Rudy, and it would be a nice small spreadsheet or flat file that just looked like this. But some customers order more than one thing at a time. So Paul Smith placed this order, and he ordered 1, 2, 3, 4 different items, and sometimes ordered different quantities of an item. Now we need to add more columns to our spreadsheet, our flat file, if we do it this way. And all of those other columns are going to be empty for the other customers. Also, you can see here there was one other customer that ordered more than one thing, but most people just ordered one thing. Paul Smith, however, called back a different time, same address, and he placed another order here. So it's just not a very efficient way of storing data if what we use is what we're kind of used to is just a spreadsheet, and just start putting in each one as each item as a new row. Once again, just to review, in the attribute table, we have each row is associated with a feature on the map, and we call each of those rows a record. And then each column is an attribute in the attribute table, and sometimes we also call those items. So the rows and columns are always put in this way in an attribute table, and with each row being associated with one feature on the map. One other thing to remember with all of this stuff with attribute tables and databases is kind of a big picture. We have servers and clients in GIS and in other applications, but this is specifically towards GIS here. And we can think of on the bottom level here, we have these databases or geodatabases, which are storing the information. They pass through some application server, and then they finally get to a client. The client could be a software that we're running, or it could be a web page, or it could be an API or an applications programming interface. All of these things can provide data from the database to put onto our maps. They might have a geographic component with them to help draw the maps, and they're passing through some sort of application server in the middle here. We're not going to get into a lot of detail on this, but just to understand that that this data is often being stored remotely. It's being accessed for all sort of different applications, and it's passing through these application servers in the middle.